I'd like to introduce Wane, who's been working both in Puerto Rico and Indiana on new secure communications systems to link basically sensors to not only generation, but also to users all at the same time. So, Brian, you've got the virtual screen, as it were, on the mic.
Yes, you did. Hi, I'm Brian Wane. It's nice to be here. Thanks for everyone's time and attention. So XQ is a smart data protection platform that provides encryption as a service. We have been lucky enough to work with NEMA on his advanced renewable power mobile power grid, and with Sean Hendricks from the Indiana 5G zone on that as well. But just to get started a little bit about XQ, we are a service that securely tracks your data wherever it goes on one united platform. So you can use our APIs and SDKs to integrate into any application that's out there and speak securely across different platforms. Next slide, please. So it's a new distributed architecture. Better to just go into the benefits of it. We're quantum safe. We stream quantum random numbers to the edge. We are crypto agile, so we're able to use the most recent cryptographic algorithms available. Every event within the network, or actually outside the network, everything that happens to your data is logged with geolocation and identity, and we're built for scale, so we can move to billions and trillions of transactions a day. Next slide, please. So this takes us a little bit more deeply into the mobile microgrid that Nima was just describing. And specifically, I'm going to talk about the encryption and security. So we're talking about smart energy and encryption here, and smart energy and security. So we look at the mobile power grid. As Nima mentioned, it can connect to any different type of energy source. So that can be solar, that can be wind, that can be diesel. Now, when we think about like what's the purpose of a mobile power grid or a nano grid, this may be obvious, but it functions without being connected to the main power grid. It can connect and it can serve power back into it. But essentially, when we think about what this thing does, is it brings in the energy resources and it stores that stuff in a battery, right? And then it distributes the energy intelligently, right? So we can call this like an islanded electrical grid. Attached to this is the cyber server. And the cyber server is just a very smart IoT gateway, which is essentially like a Linux with a 5G antenna on it. So all the information that's coming out of the energy management system goes into the cyber server, and then it's managed by the XQ application, where it's encrypted. We talk to the XQ cloud platform, generate our keys at the edge, encrypt things, send the information back to the cloud platform, and then through the cyber server, connect to the 5G network to send information out through the internet to the reporting portal and the InfiniGrid. And at InfiniGrid, that data is analyzed, it's monitored, it's made sure that everything is working at peak capacity. Within the reporting portal at the moment, we'll display all that information. Now, what's great about this is because it's 5G, it's super fast, low latency, but also the ability to send information back and forth. So mobile terminate, so is what we say. So normally if it's your phone and your phone is essentially an IoT device, just like this is, makes calls out to the grid, to the cloud. So that's mobile originate. The interesting thing about about 5G is that it has the power to mobile terminate, so take information back in across the network. So when the information goes across over to the reporting portal, it's transferred with a token. That token is sent back to the XQ cloud platform with the identity and says, hey, is this information expired? Do I have the correct policies? Great, I do. Here's the key, decrypt it. So it's safe. Now, every packet of information that goes across this is kept secure by a different quantum safe key. So the advantage of that is, if someone breaks into the grid or the device itself, they only get that one packet of information. So you can see this as a one mobile power grid, but NEMA is working on contracts for thousands within certain countries. So if he was managing 4,000 mobile power units within, let's say South Africa, even if one is compromised or one bit of information is compromised, this particular setup, this platform keeps the rest of the grid safe from attack. And that's a unique feature to our approach to security. If you are interested in exploring our platform, you can go to xqmessage.com, sign up for free, get an API code and some demo code, and get going. Love to see what you come up with. So why is this important, and what impact is smart energy and security going to have, right? So the ultra low latency that's supplied by 5G and combine that with strong security, it's going to create the confidence to run mission critical applications that demand absolute reliability and responsiveness. This includes things like, life and death situations. We want to prevent sort of outages, things that happened in Texas recently. So the current advanced energy industry is worth about $1.3 trillion globally. The US government labels this as one of the 16 critical infrastructure sectors considered vital, absolutely vital. Its incapacity, and quote, its incapacity or destruction would have a debilitating effect on security, national economic security, and national public health and safety. So the government itself sees this not just as an economic engine, but as a public safety sort of source and center. So you think, is anybody really going to hack the grid? I mean, what's the benefit of that? I mean, well, they're willing to go after elections. Why not energy as well? So a Puerto Rican utility recently estimated that if someone were to tamper with the wireless smart meters, it could cost them up to $400 million per year. Recently, I think it was December, the solar winds attack. Lots of publicity around that. Some of the things that may not have come out is that some of the victims there were also the US Department of Energy, the New York Power Authority, as well as 18,000 other total organizations. So there is risk here, and the impact could be catastrophic should something happen to the energy grid as a whole, the power system that's available, not just within the US, but globally. So it's not just the main grid. There are other areas and systems as well that have that are vulnerable, right? So say for instance, just renewable turbines. They're very easy to get into physically. After that, being able to hack a farm itself, they'll lose $30,000 of revenue per hour, and it's very easy to destroy the turbines totally as well. A malware attack in the Ukraine recently was a novel malware attack. I mean, that brought rolling blackouts to Kiev, bringing on complete darkness. And I think this is the first example of a known malware attack against an electrical grid, which was successful. We look at like the other use cases that are available: smart grids, digitally enabled logistics, enhanced field operations, production optimization, drilling optimization, and automation. So beyond just smart grids, you can see how the other aspects of energy creation and energy management, being able to manage that data in a bidirectional fashion, knowing which parts of the logistics systems are available, knowing how your energy operations and some of the metering are functioning at any particular time are important. You can look at, if we take a simple example of like wellheads. Right now, the middle of Wyoming, it may take each wellhead may be 25, 50 miles apart. One individual can manage maybe 5 wellheads. If we're able to create a system where through 5G connectivity and other localized data management on those wellheads, a single operative might be able to manage 15 to 20 wellheads, and you can see how obviously there are economic benefits there. So if we look at just how IoT for enterprise, that market size is affected, because the smart energy needs resilience across autonomous vehicles, across agriculture, across manufacturing, construction, supply chain, and agriculture. Right now, we're looking at like about 9 billion devices that are out there right now. Within 5 years, it's going to grow to over 25 billion devices. We see there's an estimated GDP growth of between 1.2 trillion and 2 trillion by 2030. So there's an enormous economic impact, and specifically like within a few key verticals in the economy. As I said before, manufacturing, construction, and mining. The IoT market opportunities are such that, you know, energy and utilities are key here for real-time automation specifically. But without energy, you're not going to have the support of auto, the ability to support auto, healthcare, manufacturing, healthcare, and public safety. So these are the other key aspects of the economy that'll grow through IoT, and the proliferation are dependent on smart and resilient energy. And then we can see that 5G and IoT will transform every aspect of industry. Critical infrastructure is going to be vital to that. And some of the types of devices like NEMA and advanced renewable power that they're creating and bringing to the world have the opportunity to change people's lives globally, whether that's within education, public safety, transportation, manufacturing, and general energy resilience. Thank you very much. That's my presentation.
One comment I'd love your thought on is a number of the presenters before you, Andrew Dicker, Jose Casillas, and Sean, really talked about the interconnection between different systems. So it's really smart energy connecting to smart transportation, connecting to digital agriculture. Could you make a comment on the importance of being able to do secure communications across different systems? Because a lot of people talk about security within a system. And I think what we're finding is cross-platform security or security from domain to domain is becoming a critical element. And if you could comment on, is that something you're seeing in all your projects? Just would love your thought on that.
Well, certainly, like the ability to have security within energy supports the basic functionality of autonomous manufacturing and other systems. But certainly, like, you would want autonomous or manufacturing to know if there was a problem with one energy system and be able to switch over to something else. That ability to communicate between the different systems across platform is going to be vital, and to do that securely, so that you wouldn't subject your various systems to the possibility of blackout and failure through one vulnerability in one system allowing vulnerabilities in others as well.
Great. Thanks for that.